Hello and welcome to another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 4, Lesson 2 on more work graphing linear functions. In other words, more work graphing lines. We definitely reviewed this in the last lesson, so if you didn't watch Unit 4, Lesson 1, make sure that you get caught up on the basics of linear functions, i.e. the equations of lines, how to use their slope and their y-intercept to graph them. Today we're going to get a little bit more advanced work on that, all right, while at the same time kind of emphasizing what both the slope and the y-intercept tell us. So let's get right into that. Here we go, slope and y-intercept. The graphs of linear functions depend on their slope and their y-intercept. And it's critical to understand how these two parameters, as we call them, affect the line's graph. Okay? And a nice way to do that is to start off with a problem like exercise number 1. Let's take a look. 4 linear functions are graphed on the set of axes below. Write the number of the line beside each equation based on its slope and its y-intercept. Okay, this is kind of cool, right? I want you to pause the video now and without using your graphing calculator, just using your knowledge about slope and y-intercept, I want to see if you can figure out which equation goes with which line. Pause the video now and see what you can figure out. Well, it's up to you. Do you start here and then work this way or the other way around? I'm going to actually start with the equation and figure out which line goes with it. Now, when I look at A, right, what do I know? I know its slope is -2/3 and I know its y-intercept is 3. So whichever line I'm looking for must have a negative slope, so the line must be decreasing, and it's got to have a positive y-intercept. The only line that has a negative slope and a positive y-intercept is choice 4, right? Choice 4 has a negative slope because the line is going down, and its y-intercept is right there, so it's got a positive y-intercept. All right, so that's choice 4. Let me just erase that. Now, letter B might be a bit confusing. Y equals x plus 5, because you might look at that and go, well, I don't know what the slope is, all right? But the plain fact is, the slope on this one, let me write that a little bit bigger there, can be thought of as 1. Not thought of, but is, right? It's 1 times x plus 5, so its slope is a positive 1, its y-intercept is a positive 5, which means that I'm looking for a line that increases and has a positive slope. And that happens to be this. It happens to be line 3, right? Line 3 has a positive slope and a positive y-intercept. And we can just keep doing that. Letter C has a slope of -2 and a y-intercept of -7. And the only line with a slope of a slope that's negative and a y-intercept that's negative is this guy down here, or line number 1, all right? So line number 1 has that negative slope and that negative y-intercept. And finally, the only other one that's possible, right, is this line, y equals 2x plus 3, which has a positive 2 as its slope and a negative 3 as its y-intercept. And the only line that has a positive slope and a negative y-intercept is right here, and it's choice 2. All right, so that is a great exercise for you to do a few different things. One, can you look at an equation and tell what its slope is, what its y-intercept is, and whether they're positive or negative? And then can you tell, based on that, right, what the line should generally look like? Let's keep going. All right. If we can identify the slope and the y-intercept of a line from its equation, then we can use this information to graph the line. So let's review how that's done. Exercise number 2. On the grid below, graph the equation y equals 3/2 x plus 4. First identify its slope and y-intercept, then graph the line on the grid provided. Awesome. All right, what I'd like you to do is pause the video now and go ahead and identify the slope, the y-intercept, and graph the line. All right, well, here we go. It's already written in beautiful y equals mx plus b form for me. So my slope happens to be 3/2. My y-intercept happens to be positive 4. Remember, the slope doesn't include the x. Please don't tell me the slope isn't 3/2 x. It's not. Now I can graph the line by plotting my y-intercept at positive 4. I can now go to the right 2 and up 3, to the right 2 and up 3. I can reverse that, go down 3 and to the left 2, down 3 and to the left 2, and I end up having that line. All right, excellent. Let's take a look at exercise 3, which builds off of exercise 2. Let's take a look. Pick two sets of coordinate points that lie on the line and find the average rate of change between the 2 points. What are both equal to? All right, well, let's just make sure that we've got our line kind of graphed down here as well. So that's the same line as what I graphed up there, just, down here and nicer. All right. The idea is, you now, right, can easily find 1, 2, 3, 4, 5 different coordinate points that nicely fall on this line. Of course, there's an infinite number of points that lie on this line, as there are on any line. All right. But I want you to take two sets of points. For instance, here, let's do one with us, right? Let's take the point 0, 4, and how about the point 4, 10? And let's calculate the average rate of change, right? The average rate of change is delta y over delta x. So that's going to be 10 minus 4 all over 4 minus 0. That's 6 divided by 4. And if I write that in simplest terms, that's 3/2. Okay? What I'd like you to do is take two other points that lie on this line and calculate the average rate of change that lie between them. Pause the video now and go ahead and do that. All right, well, look, the easiest thing is to sort of take two consecutive points that lie on the line, and that's fine. The only thing there is you'll definitely get 3/2, and you won't even have to reduce it. So I'm going to grab a couple that are far, far apart from each other. In fact, I'd like to grab this line down, this point down here, which is at -4, -2, and I think I'm going to grab the one way up here, which is at 4, 10. All right, I'm going to calculate my average rate of change there. So delta y over delta x gives me 10 minus -2. Got to be a little careful there. 4 minus -4. 10 minus -2 is 12. 4 minus -4 is +8. 12/8, if I divide both numerator and denominator by 4, 12 divided by 4 is 3, 8 divided by 4 is 2, and I get 3/2 again. By the way, the purpose, of course, of exercise 3 is yet again emphasizing that on a line, if you pick any 2 points, whether they're close together, far apart, they could be just microscopically close together, or they could be way, way out there, way, way down here. If you calculate the average rate of change between those 2 points, you will end up getting the slope of that line, right? It didn't matter what 2 points we picked. And that is the defining characteristic of a linear function. Any linear function has a constant rate of change. And any function with a constant rate of change is a linear function. Now let's talk about rewriting equations of lines. Sometimes, unfortunately, sometimes linear equations are not written in a form that makes it easy to determine the slope and the y-intercept, okay? A lot of times, for whatever reason, you have both the x's and the y's on the same side of the equation. Maybe the y's not all by itself. But the plain fact is the only way you can identify those important parameters of slope and y-intercept is if the equation looks like y equals mx plus b. Unless it looks like that, you can't say what the slope and the y-intercept is. So let's take a look at an algebraic, reorganization of an equation. Specifically, let's look at rearranging 2y minus 6x equals 12. Let's justify the steps that we take to rearrange it, okay? And then we'll identify the slope and the y-intercept. Let's take a look at exercise number 4. Consider the linear equation given by 2y minus 6x equals 12. Letter A. Steps are shown below that rearrange this equation. Justify each step with a property of equality or a property of numbers. All right? So this is just back to how do you justify manipulating an equation. Now again, the reason I want to emphasize how important this is if I gave you this and I said that was the equation of a line, what's its slope, what's its y-intercept, I'd be very worried that some of you would say, well, the slope is the number multiplying x, so that's -6, and the y-intercept is the number all by itself, so that's 12. But the slope and the y-intercept of this line are not -6 and 12, and that's because it's not written in y equals m times x plus b form. So what exactly happens? Well, in the first step, it appears that a 6x is added to both sides of this equation, right? How do we justify that? Well, we justify that with the addition property of equality. All right, so the addition property of equality justifies the fact that, hey, I know I got to get that x on the other side, so I'm just going to add a 6x to both sides. Really what I'm doing, right, is I need to isolate y. So I'm just undoing what's happened to y. And what's happened to y? We've multiplied by 2, and we subtracted a 6x. To undo that, I'm going to add a 6x to both sides, and eventually I'll divide by 2. Not yet, though. Right at this point, right, I take that 12 plus 6x and I switch it into 6x plus 12 because I really want that mx plus b, right? So what allows me to take 12 plus 6x and rewrite it as 6x plus 12? Well, that's that beautiful commutative property. And technically, it's the commutative property of addition. I'm going to just abbreviate it as commutative prop of add, right? That's it. Right now, if I really want to get y all by itself, I divide both sides of the equation by 2, right? I'm trying to isolate y, so I divide both sides of the equation by 2. What gives me permission to do that? Well, technically, it's the multiplication property of equality. I don't think I'd have a real big beef with any student who said the division property of equality, right? But remember, I can really think about that as not dividing by 2, but multiplying by 1/2, whatever. And then finally, I take this expression and I divide the 6x by 2, and I divide the 12 by 2, right? And what allows me to do that? Well, that's the distributive property, right? And of course, once I do the distributive property, right, then I do 6 divided by 2, I get 3. I get 12 divided by 2, I get 6. And I've taken this equation, 2y minus 6x equals 12, and I've rewritten it as y equals 3x plus 6. That equation and that equation are equivalent equations. Any coordinate pair that makes this one true will make this one true because I've used properties of equality and properties of numbers to write equivalent expressions. But now the cool thing is I could graph this. And I could graph it because I should be able to identify the slope and the y-intercept. Let's just do that together. The slope now is the number multiplying x, so the slope is 3 or 3 over 1, and the y-intercept is 6. But it's only when we have a line written as y equals a number times x plus another number that we can identify the slope as being the number multiplying x and the number that's being added on as being the y-intercept. So let's get some practice with this because it's remarkable how often this can actually come up. It's actually a little unfortunate how often this can come up. I just can't quite get this to, there we go. All right. I don't know. Let's take a look at exercise number 5. Rearrange each of the following linear equations into y equals mx plus b form and identify the slope and the y-intercept. Okay, I want you to look at this really as like solving these equations for y. I want to get y all by themselves. So let's take a look at letter A. I'm just going to write this a bit bigger so that we can really see it on the board. And I want you to think about this just the way we thought about inverses, and solving an equation by applying inverses. When I look at this thing, if I want to get y all by itself, right, I have multiplied y by 3, and then I've subtracted 3x from it. If I want to get y all by itself, I have to first add 3x to get rid of subtracting the 3x, and then I have to divide by the 3. So it's a piece of cake, right? Now I'm going to take advantage of the commutative property of addition right away, and I'm going to write that right-hand side as 3x plus 15. I really probably should write it as 15 plus 3x, but I'm just going to automatically be like, hey, 15 plus 3x and 3x plus 15 are the same thing, so I'm just going to write it as 3x plus 15. Now, to go on, I'm now going to divide both sides by 3, and I need to be careful here, because I really need to distribute that division by 3. But then I get 3x divided by 3, which is just x. I get 15 divided by 3, which is just 5. And now I have it in y equals mx plus b form. I can identify the slope. The slope in this case is 1. That's a little bit tricky. The y-intercept, though, is a piece of cake. It's equal to 5. Right? So I could now rip this one out. I could easily graph it. Now this is, by the way, kind of maybe a little bit of a difference between 8th grade work with graphing lines and 9th grade work with graphing lines, right? In 8th grade math, typically all lines that you ever have to graph, right, are given to you just already in this like y equals mx plus b form. Maybe you had an 8th grade teacher that had you do this. You know, that was definitely within the realm of possibility. But most of the time, they probably just gave you the equation of a line that you could just go for it, right? Go ahead and graph it. In this course, oftentimes you will have lines given in kind of these types of forms, which makes it a little bit more difficult. Let's do one more together, and then we'll have you do the last two on your own. Again, let me rewrite letter B down a little bit bigger so that you can see it. I've got 2y plus 5x is equal to negative 8. Again, just like before, I want to think about how to isolate y. Well, I've multiplied y by 2, and I've added 5x. So I'm going to subtract 5x, and then I'm going to divide by 2. So that's simple. Okay, so let me subtract 5x from both sides. Again, I'm going to take advantage of the commutative property of addition and write that as negative 5x minus 8 as opposed to negative 8 minus 5x. I'm now going to divide both sides by 2 and distribute that division. Now, the first thing I really can't do much with. I just have to leave it as negative 5 halves x, but that's okay. In the second part, I've got 8 divided by 2, and I can just write that as 4. Now it's pretty easy to identify the slope. That's going to be negative 5 halves, and the y-intercept is going to be negative 4. Okay, great. So this is it's almost always basically a 2 to 3 step procedure, depending on like how much you have to do to isolate the y. Very often you have to move an x term over to the other side of the equation by addition or subtraction. And then you have to get rid of a coefficient multiplying y by doing division. Sometimes. All right. So what I'd like you to do now is pause the video and try letter C and letter D. You may want to rewrite them to begin if that helps. If not, just go for it. Take a little bit of time now to work through each one of those. All right, as usual, of course, I did the 2 easy ones and let you loose on the 2 harder ones. All right, now notice this first one has the x written first. If you're comfortable with that, that's fine. If you're not comfortable with it, use the commutative property to rewrite it as negative 3y plus x equals 6. If you don't need to write this line down because you're comfortable with it this way, that's fine. But I really like looking at it like this because now I can easily say, look, what I'm going to have to do is subtract an x from both sides, and then I'm going to have to divide both sides by a negative 3, right? I got to do that to isolate the y. So let's get rid of that x first. I'm going to subtract an x from both sides. Again, I'm going to use the commutative property of addition to just immediately write the right-hand side as negative x plus 6. I'm now going to divide by negative 3, divide by negative 3, divide by negative 3. Here's where it might get a little bit tricky, okay? Right, I've got negative x divided by negative 3, and I really want to look at that as negative 1x divided by negative 3, okay? So, you know, I have y equals negative 1 over negative 3x. 6 divided by negative 3 is negative 2, so I've got that. Now, I shouldn't leave it this way. A negative divided by a negative is a positive. So anytime you see a fraction where the numerator is negative, the denominator is negative, you gotta change it to a positive fraction. You just have to, right? So my final answer now is y equals 1/3 x minus 2, right? Where the slope now is 1/3 and the y-intercept is -2. Okay, simple enough. Let's take a look at letter D. Letter D has exactly the same kind of considerations in it. I might need to rewrite this as -4y plus 6x is equal to -20, in which case I'm going to subtract a -6x from both sides. I'll get -4y is equal to -6x minus 20. Divide by -4, divide by -4, divide by -4. Now I've got -6 divided by -4. A negative divided by a negative is a positive, and I can reduce both of them down by a factor of 2. So that's going to be a positive 3/2. -20 divided by -4 is positive 5. So my final equation there, y equals 3/2 x plus 5, tells me I've got a slope of 3/2, and I've got a y-intercept of 5. Absolutely critical to be able to do this. You're going to have a bunch of problems on the homework where you've got to rearrange the equations in order to identify their slopes and y-intercepts. But in Algebra 1, we will often be given equations of lines for whatever reason where both the x and the y variables are on the same side of the equation, and you've got to rearrange the equation to isolate the y variable. All you have to do is undo what's been done to y in the opposite order. All right. Let's summarize, right? Today we looked at a bunch of different things, right? And pretty much most of it was review, right? How do you look at the equation of a line and identify its slope and its y-intercept? How do you take a line that maybe isn't written in that form and use algebra to rearrange it so that you can identify the slope and the y-intercept? All of these are very important skills as we move forward, because this entire unit is going to be devoted to linear functions, right? Which means we've got to be able to graph lines, we've got to be able to think about slopes of lines and y-intercepts of lines, all right? We've got to be able to do that. So get a lot of practice on the homework. For now though, I want to thank you for joining me for another Algebra 1 lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.